Hey folks, I'm just back from Sea Otter. I went on Friday and Saturday. Um, it was neat. I hadn't been in 7 years or something like that. Um, it's Sea Otter, so not a lot has changed. There was a lot of interesting new things, a lot of belt drives and uh, what's it called? Uh, hub gearboxes. Yeah. Um, some other cool stuff. I had a few discussions. I'll post those up on a post. Um, but I was gonna show you something here. This gets into the master part modeling that I've been doing in SolidWorks, and I've been putting a lot of effort into redesigning dropouts again. And I wanted to show something that's very important from a master part perspective so that you understand. Let's take a look at this file here. This is an earlier file. Here's the master part. We've got our planes and everything like that in the master part. And if you notice when we get into our feature tree here, I'm not creating any geometry outside of the master part. And if I was to select here, you'd see that this sketch is referring to items in the master part directly, mainly planes. So I haven't cluttered up the file with any extraneous stuff. I'm just going directly into the master part. Everything looks nice and clean here, and it's uncluttered. As opposed to this one, where I've got my master part, and then I've got all these construction geometries that refer to the master part, and then I make my part. So otherwise identical constructions, just the first one here is referencing the master part entirely. On the second, these, if we go here and I go to that boss, you'll notice it's referring to internal geometry. See how it's pointing to there? Not the master part. But if I was going to go to this, that refers to the master part. Okay, now why am I showing this? Well, because I've been talking a lot about master part modeling, we were looking for durable models. And let's say something happens to this master part or it needs to be updated because there's some goofball stuff in SolidWorks having to do with their program and how it works. Let's say something happens and for some reason I have to delete that master part or it is lost or something like that. Let's see what happens when we delete the master part in this part setup. Gonna wait a few seconds. Here, I'll maximize. Well, I should have maximized earlier. But we're gonna wait for it to think. I'm not on the fastest computer here. Okay, it goes to, okay, you want to delete all this stuff. Well, I'm gonna go to advanced. So it's only deleting what it has to delete within the part to delete that file, which is a pain in the butt. But let's say we have to do it. So we say yes, and we're minimizing our deletions. Well, look what happened to our part. It completely blew up, utterly destroyed, and we don't even know what geometry any of these sketches were on because the geometry was in the master part. So that's not good. That's not a durable setup. We can't refer directly to the master part in that sense. Well, then let's look at this part here. If you notice, again, I've got construction geometry within our part. I'm going to go in and delete the master part. Preferably you'd be replacing the master part or updating it or something like that, or maybe it changed its name. But if you notice here, only two things are getting deleted. The move body, and that's to place the master part, and the coincident, and that's mating the master part using the coordinate system. So we say yes. And we wait. And come on. This is my life. I need a faster computer. But this is actually some extremely complex parts. Like most people don't have this level of complexity. Now look what happened. All my construction geometry here that was referencing the master part are failing. They still exist, but they've lost their reference. But when we get down here and we look at the construction's all there. Nothing has failed of the actual part. All I have to do is insert a new master part or repair what's going wrong, and then I can reassociate these references here. So what I'm trying to show here is that you want to, in a way, translate everything in the master part that you're going to use. This is a goofball. This should have been there. But anyway, everything you're going to use, and this is all the construction geometry out of the master part that I'm using in this part. So there's a lot of information there because we need to know a lot of things about seat stays and chain stays and various other hub information or brake information in here. So I bring it in, but I can just quickly update it. Let's do we want to do that? Let's do that. Let's insert the master part. Part and browse, and we're going to go to here. You get this master frame. Okay, we're inserting this, and we look at all of our stuff. I don't need this information. I'm just going to get some coordinate positions and axes and planes. And if you don't see, it locates with move copy feature. So we go here. And now it's going to go, okay, where do you want this thing and how do you want it? So I'm going to select the origin, and I'm going to have to go down to the bottom because that's where this is. If you look at, I have a universal, a user coordinate system here, and I have to make sure I go align axes. So now with a single mate, I'm putting an entire bicycle's worth of geometry into this part, and then I can reassociate. So let's go here. Now, of course, I should have moved this all the way to the top. Let's do that. Come on. This is nice. Boy, this hates me. Here, we'll just throw it here because we don't want to wait all day. All right. See, I had this planned out. Okay, so there's our master part, and it's ahead of these parts. Let's say the chainstay plane here, right? We want to reassociate this. And I can go into planes here. And granted, all of these are for the whole bicycle. This is everything. So I'm going to go to chainstay. Plane actual. I can show that. So now I'm showing two planes. Oh, there's another trick you need to know. So now I'm going to go here, and if you notice, there's nothing there. That's why it's failing. So I'm going to go, whoops. Whoops, SolidWorks has some buggy stuff. So I'm going to go in and select this entirely here, like this. Once you're used to doing all this stuff. So there it is. Chainstay, plane, actual. Boom. And if this goes all according to plan, we rebuild and you'll see that that's reassociated. Oh no, see, see this, I should have made it coincident, not 0 millimeters. Let's fix that. Notice, okay, well, you'll see here, now that is correct and everything's good. Everything's updating. But I'm going to go back here, and this is another trick that you need to know. And all this stuff, it takes years to learn this stuff. I'm going to make it coincident. Now, 0 millimeters and coincident should mean exactly the same thing. And functionally, they do in almost every use case. The problem comes is that with a distance mate, if I go to delete the master part, it's actually going to delete that feature. But if it's coincident, it's not going to delete that feature. It's this really kind of just weird, unexplainable bug within SolidWorks that it won't do that. And I could probably set up an explanation for it. But the key here is always just use coincident mates for your geometries, for your planes. Now, I've discussed this before. You can't really translate axes into parts from master parts. I should probably just do away with that, but they come in handy sometime for visualization. Mainly it's just planes, and you make them coincident, and there you go. Look at that. I've fixed this, and yeah, it's a pain in the butt. I have to go down and fix every one of these, but I don't have to recreate my whole part. It's like, it's a house cleaning issue, and in the grand scheme of things, given what you're leveraging, it's worth it. And you don't swap out master parts willy-nilly. It's not a thing that happens a lot. But I just wanted to clarify these details because they come up and you can freak out and everything's gone bad. But following certain practices makes a big difference, okay? Thank you very much. Hope you enjoy.